Okay, so hopefully this video is going to be a little bit of review and it's just going to bring together some things that you've already figured out on your own. Okay, so what I have here is an isosceles right triangle. And real quickly, if this is isosceles, then these two angles need to be 45. And I'm going to let you figure that out if you weren't sure already why that's true, but it is. So we're going to call this special right triangle 45, 45, 90, right? Those are the degrees of this triangle. And if you notice, the side across from the 45s are both equal, and we're going to say they're both x's. Okay, we don't really know what they are. It doesn't matter. We just know they're equal to each other. Now we're going to do the Pythagorean theorem to figure out the hypotenuse. So we're going to say x squared plus x squared equals, we'll call it question mark squared. Okay, so 2x squared is equal to question mark squared. So the question mark is equal to the square root of 2x squared. When we simplify this square root, this has a perfect square, x. 2 does not, so we get x root 2. Okay, so that means this side, let's see if I can erase this, at least the circle, is equal to x times the square root of 2. So this side is x times the square root of 2. So this becomes a really big deal. Okay, so what this means is that if I have any isosceles right triangle, okay, and I know one side, so this is isosceles, I know this is 3, then this other side has to be 3 because it's isosceles, and this has to be 3 times the square root of 2. Kind of cool. This becomes a really big deal, and this will be a big deal for like every math class for the rest of time. Okay, the special right triangle, 45, 45, 90, x, x root 2. Okay? I think that gets a little, and it's not more complicated, it's just a little bit harder, is let's say I have my isosceles right triangle and I say, here's an easier version, this is 7 root 2. What are the other sides? So if we remember, it's x root 2. So we think, oh, this is the x root 2 side because it's the hypotenuse. So x root 2 is equal to 7 root 2. So clearly x is 7, right? That's pretty straightforward. Where it gets annoying is if you have your isosceles right triangle and the side is, say, 8. Okay, what are the other sides? So again, what you need to think about, this is the x root 2 side. So 8 is the x root 2 side. Can you solve that equation for x? Absolutely. We're going to divide by root 2, right? So we get 8 over root 2 is equal to x. So that's what these sides are, is x over 8 over root 2. But we do want to rationalize the denominator. So let's go ahead and do that. So we get 8 root 2 over 2, which then when we simplify, right, we can reduce this. We get 4 root 2. Okay, so that's our x, which means this, each side, I know that's not super clear, is 4 root 2. Okay, so for now, we're just going to use special right triangles to find the sides of missing, or find the lengths of missing sides of a right triangle. We're going to just have a myriad of problems. We're going to say this is isosceles, find these sides given that's 10, or if this is 8, what's that? Okay, you should be able to do all of these types of problems, okay?